So in 9.5, we're looking at inheritance hierarchies. And I've mentioned one of the difficulties in Unit 9 is we're not going to be able to really answer all of the why questions in great detail. That would require writing very large amounts of code. But they do mention, some of the why reasoning, why we might like to create these inheritance hierarchies. Um, and we'll talk about some of them. They mentioned like how you might avoid rewriting or copying code, and I'll mention how that would be possible coming up. And there's also some storage assets of using inheritance. We'll take a look at that. One of the first things we really have to understand in section 5 is right here. It says that a superclass reference, okay, can hold an object of that superclass or any of its subclasses. Okay, so like if we looked up at this shape diagram, if we made a shape variable, so shape x equals, well, we could put a rectangle in there or a triangle or an ellipse or a circle or a square or a shape. It could hold any of those. Since these are all subclasses of shape, that shape variable could hold any of those objects. We'll notice, though, that the opposite is not true. So you can't go in the reverse direction. In other words, you couldn't make a subclass variable like a square and try to have it hold on to a shape. Okay. There's things that you could do regarding cast, and we'll look at that coming up. One of the reasons that we do this, it mentions, is we could use arrays, we could use list, and we could use parameters of this superclass type and make our methods a little bit more broad. I wouldn't get too worried about this whole S and T thing. If you need some help deciphering it, let me know. But let me show you another example that I was using in class where we had kind of this, it's not really Mario Kart, but it's similar. Okay. But in this kart game, we have a vehicle, and it could be a cart or a bike or an ATV. These will all be subclasses of the vehicle class. The nice thing about doing this then is in our garage class, we could make an array of type vehicle, or it could be an array list. It really wouldn't matter, depending on what you want your game to do. But let's say you made a vehicle array. That array could then hold on to carts or bikes or ATVs. If we didn't have this, we'd have to make a separate array to hold carts, a separate array to hold bikes, and a separate array to hold ATVs. And later in your game, if you wanted to introduce a skateboard or a hovercraft or a rocket ship or a boat, you'd have to make new arrays to hold those also. And if our character in our game had a garage, which had a vehicle array, again, if you then started making more vehicles and you didn't have a vehicle class, you'd have to go in and start changing all your character code too to interact with this new vehicle. But if a character has a garage, which has an array of vehicles, well, we could add more vehicle types and really not make any code changes to our garage or our character class, since it's just going to be interacting with things of type vehicle. If we extend the vehicle class and add more types of carts or bikes or whatever, it's going to be a real easy modification. If we had a method in this garage class that said something like add vehicle, and it was expecting a vehicle parameter, okay, so maybe like a vehicle V right here. Well, again, it'd actually be really easy for this to work with what we want. Now, that add vehicle could accept a cart, it could accept a bike, it could accept an ATV, any of those things that you wanted to give it. Okay, it'd be real simple to interact with all of this stuff. So a character has a garage which has many vehicles, and then that vehicle could be a cart, a bike, an ATV, whatever you wanted. And then that other big note in CS Awesome was saying that if we made a vehicle variable, okay, maybe I'll call it like V1, that could be a new cart. Okay, so that's one option. All right, I got some other options too. I could make some other vehicles here. Maybe I'll make a V2 and I'll make a V3, and maybe this one's a bike, right? Maybe this one's going to be an ATV. Maybe the next one's going to be a supercart. You know, again, this vehicle variable could hold any of these, and it can actually change its mind. So, like later, let's say I change my mind and I want V2 to become a new ATV. That's totally fine. Okay. The variable could hold any of those types of objects, and it could later change. And in addition, okay, I could even create like a cart and I could give it a supercart. Now, there's some things that I can't do also, and it's probably equally as important that we understand what the things that we can't do are. So I couldn't make a cart, maybe call it K2 and try to put in like a new vehicle. So we can't give a superclass object to a subclass variable. That's illegal. Okay, so I'll comment that one out just to remind us that that's not allowed. All right. And like another thing that I couldn't do, I couldn't take a cart and try to put a new bike in it. So we can't go across the structure either. Okay, so that's also going to be illegal. All right, but these other things that I was saying, those are all fine. And a cart can hold on to a cart, a vehicle can hold on to a vehicle. We already knew that. But what we're doing here is we're setting up the basis for polymorphism. Okay. All right. So this is the main idea in section 5, understanding like these different variable types that you could create. Well, if you notice, I put some methods over here in my vehicle and my cart and my supercart. Okay. The polymorphism kicks in when we take like these vehicles here. So like V1 is a cart, V4 is a supercart, or if I made another one here and I made it a vehicle, and I start calling those methods, that's when we're going to see this polymorphic activity. So objects have what we call a declared type and an actual type. Whatever you see on the left, this is the declared type, okay? And then what you see over here on the right, this is their actual type. And if we go back to CS Awesome real quickly, it kind of shows this really nicely. So if you look at CS Awesome 9.6, okay, they talk about the declared type and the actual type. So the declared type is used when we compile our code. The actual types is used at the runtime. Java has two-stage error detection. So first it compiles all of your code and it checks for errors. And if it passes that test, it allows the code to run. And it doesn't quite mean that you're bulletproof at that point, because you might still run into a runtime error. You could divide by 0. You might go out of bounds. Not everything gets checked at the compile time. Okay. But it does check for the legality of like all of the method calls that you're going to make. And when it does this, it's only going to look at the declared type. It won't actually look at the actual type when it's checking for the legality of the method calls. So the compiler will check the declared type has the method or inherits the method from being used and give an error if it doesn't find it. All right, that's a real interesting line of code. Now they're talking about something with an interface there, which we don't have to quite fully understand. But we should understand that sentence that I have highlighted. So the compiler is going to check on the declared type if it can run a method. All right. Well, if you've looked at my 9.6 code again, so I've got my supercart here, and my supercart can do 3 different things. Okay. Any of those 3 things it can do. I've got my cart here, and the cart can do these 2 things. It can get type, it can get num wheels. Well, there's one missing there. So I didn't put in the method called get turbocharged. And it doesn't inherit it. Supercart inherits from cart, but not vice versa. So if we took this method and we tried to call it on a cart, we'd get an error. Okay, that makes sense because it's not in there. And then if you check my vehicle class, all right, it's got a lot of methods, but the only one we're going to deal with right here is this get type method. What we won't see in here is get number of wheels or get turbocharged. Those I didn't put in here. So a vehicle can't call any of those methods. All right, well, let's look at my main method here because I've got some pretty different scenarios being run out. This is the beginning of my polymorphism. So when I start storing different types in there, again, this right here, this is your declared type, okay? Whatever we see on the left. So that's my declared type. And then over here, what I see is the actual type. It's only the declared type that gets checked by the compiler. So as far as the compiler is concerned, these are all vehicles. Now, in actuality, that's not true. V2 is actually holding onto a cart, and V3 is holding onto a supercart, which again, that's what we just saw was legal in 9.5. Superclass variables can hold subclass objects. So it's legal to do what I'm doing here, okay? And it gives us more freedom in our code. It would allow me to make one array to hold all those different types of objects. It would allow me to use a single parameter of type vehicle to accept all of these different types of vehicles. I wouldn't have to make different methods to add bikes or carts or ATVs. So it's a good thing that we have it, and it allows for this to happen. But it gets a little bit tricky now, because since the declared type of all of these variables is vehicle, they can only do vehicle methods. Okay, so for us, that means they can only call this method. They can't call these methods that are found in the subclasses. Inheritance only goes from the super to the sub, not in reverse. Okay, so in fact, if I took any of these method calls and I pulled back this comment here, I'd actually get an error message. Now, it's a little weird because we might look at that and think, wait, V2 is a cart. It knows what it is. It should be able to run this get num wheels method, but the compiler doesn't care what it is. The compiler only looks to this side, sees that V2 has been labeled as a vehicle. It does not retrieve the value stored in there. It doesn't check to see what it is or what it's holding on to. It just looks at the type of the variable and says that's not a valid method call. So I'm going to have to turn that one off. Now, because of polymorphism, I'm going to get a different answer on all of these. So when I run the get type method, we might think, well, wait, that means that since they're all vehicles, that they would all print or return the string vehicle, but that's not the case. We got vehicle cart and supercart. And the reason is at runtime, okay, this is after we've passed compile time, after we've already said, okay, this is legal, go ahead and proceed. At runtime, it does retrieve the value. So it does actually look up to see what's in there, and it goes, oh, there's a cart in there. And so it understands that if you call that method on a cart, that it should return cart. And it understands that if you call the get type method on an actual supercart, that you should go to the supercart class and return supercart. So the compiler just checked to see if it was legal by looking at the type of the variable. But when our code actually ran, it did retrieve the values and then behave appropriately. And I might want this stuff to work, and I might know that in actuality it could work, but it's not going to work now because these variables were labeled as vehicles. Okay. All right. If we come down a little further, keep in mind, I can't do that. I can't put a superclass into a subclass. That's illegal. Okay. So I had to comment out that line of code. If I uncomment it, I'll get an error. These two are both legal. Okay. So my cart variable can hold on to either a cart or a supercart. At compile time, K2 and K3 are basically the same thing. They're both carts. They might be holding on to opposite stuff, but at compile time, they're both treated as carts. What can carts do? Carts can get type or get num wheels. Okay, we see that there in our hierarchy, and we see that if we go into the cart class. What we don't see here is get turbocharged. So as long as we're not calling that method, then we should be okay. We can get type, we can get num wheels. We can't call get turbocharged. Even if there really is a supercart in there, and we know that, the compiler doesn't retrieve that value. So it just runs based on this idea that, oh, it's a cart, I'm not allowed to do that method. Okay. So we have to turn that one back off. But if we look at the performance of these four methods, we're going to see four different things returned. Here, the type, okay? Again, at this point, it does look up what it is, says I'm a cart. At this point, it does look up to see what it is, says I'm a supercart. This one here, if we go into the cart class, has been instructed to return 4. This one has been instructed to return 3. So we're going to see 4 and we're going to see 3, and we see those 4 outputs right here. Okay. At runtime, the values are retrieved and they do realize what they are. All right, and we can't call get turbocharged yet because it's not a valid method call for a cart. All right, if I want to create a supercart variable, I can, and I can give it a supercart. I can't give it a vehicle or a cart because those classes are super classes. We're dealing with a subclass. Maybe I shouldn't have used the word super on cart. I wasn't thinking. All right. I was giving it a different meaning here. And then now that I have my supercart SK3, okay, it can call any of these methods. And so for the first time, we can actually call get turbocharged and we get true. Now, if I know that K3 is holding a supercart and I'm convinced of it and I really want to run this method and I know it will work, but the compiler's preventing me from running it, I can do it. I'd have to apply a typecast to take this back to the to the supercart level. And if I did that typecast, what that would do is just momentarily, not permanently, but for this instance, it would change the compiler's mind. It would make it think that it was, in fact, a supercart now, as opposed to a cart. And as long as there really was a supercart in there, then everybody would be happy and it would run and it would say true. Now, if I told the computer like, hey, there's a supercart in there, but I was lying, well, then this isn't going to work. So if I did this with K2, that's not going to work because this is going to it's going to get past the compiler, but at runtime it's going to realize that I lied and it's going to crash. So it got past the compiler. You can see the code actually did start to run, but then it crashed when we got to that point. And I could have done a very similar thing here with my vehicle variables. So like if I knew there was really a cart in here, I could have told it, okay, go ahead and treat this temporarily as a cart. And then it would, okay, only for this instance though, not for any future uses of V2, but it would realize at that moment that it's a cart. It would treat it as such, and at runtime, it would retrieve the cart, call the method, and we'd get back 4. We'll learn more about that in 9.7.